Hello students, and welcome to the CompTIA Network+009 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to begin our learning path through the Network Plus exam objectives. We're going to begin with Module 1, which discusses networking concepts. In this episode, we're going to begin by discussing Section 1.1, the OSI Model. Let's begin. OSI Layer 1, the physical layer. The physical layer has several different components that's going to deal with the infrastructure and how our environment is physically set up. Your physical layer will include all of our cabling infrastructure. This will be all of your coaxial and Ethernet cables that we use to connect our devices to the network. The physical layer will also include all of the wireless network equipment that we use. These would include our wireless access points to connect to the network using a wireless internet connection. The physical layer will also deal with our data speed rate. Our data rate is going to be how fast are we transmitting data across our different network connections. And we will measure this, and depending on the speed, this could be kilobits per second, megabits per second, gigabits per second, and others. That is the different types of data speed rate that we have on the physical layer of our network. The physical layer also includes all of our network topologies. It's going to be the different types of physical layouts that we use to connect all of our network devices. Some examples include star, ring, and bus. And we will talk about the different topologies in more detail in a later episode. So just remember, with the physical layer, OSI Layer 1, the physical connections, the cable connections, the wireless equipment between our devices, the data rate speed, as well as our physical network topologies. OSI Layer 2 is the data link layer. It's going to work typically with our network switches. A switch is a network device that we use to connect all of our network devices within a local area network. At OSI Layer 2, the data link layer, we use MAC addresses for our identification. Remember, a MAC address is our media access control. The MAC address is an identifier that we have on the interface cards for all of the devices that are connected to our local area networks. We use each device's unique MAC address to send and receive data at OSI Layer 2 within all of the different segments in our local area network. At the data link layer, we have a couple features that allow us to maintain the accuracy and the integrity of our data. Our data link layer includes error detection, re-segment that in the proper order when it is received. We also have the ability at the data link layer to practice frame traffic control, can manage the speed of the data frames that are being transmitted and received within nodes or devices on the same network segment. So just remember, with OSI Layer 2, the data link layer, sending and receiving data with our switches using MAC address as the identifier. Next, we have OSI Layer 3, which is the network layer. At OSI Layer 3, we're going to be using our router devices. Routers are network devices that we use to allow devices on our local area network to communicate with external networks and the public internet. We use router devices to keep updated routing tables. Routing tables are going to be how our routers can send traffic to our internal devices on the local area network. The router is going to be where data is received from the outside, and our routers will use the routing table to forward that data to the appropriate device on our local network using the IP address that is assigned to it. At our OSI Layer 3, we also will practice packet switching. This is where we can transfer and forward data packets based on IP address assignments in our local networks. You may also see devices called Layer 3 switches. A Layer 3 switch is going to be a device that integrates both switching and routing capabilities in a single device. This is becoming a more common configuration, especially in our IPv6 networks. Our next layer is OSI Layer 4. This is the transport layer. OSI Layer 4 is going to work with the Internet Protocol. And the Internet Protocol has two different protocols that are used within the suite of IP, TCP and UDP. TCP is the Transmission Control Protocol. UDP is the User Datagram Protocol. And these are the two protocols that we use to send and receive IP data packets across our network. TCP is a protocol that uses a connection-oriented configuration. This means that when we are sending and receiving data across the network, there will be a defined beginning and endpoint of that transmission communication. With UDP, the User Datagram Protocol, we keep a persistent connection open. With TCP, we have things like error recovery, resequencing of data packets, as well as the ability to practice flow control for how fast our IP data packets are being sent and received. With UDP, we do not have any of those features. That is the key difference between TCP and UDP data transport layer. At the OSI Layer 4, we're also going to have segmentation. This is where we can send large amounts of data in smaller data packets across the network. And then at the destination, we can reassemble those data packets in the correct sequence and order. Next, we have OSI Layer 5. This is the session layer. And OSI Layers 5, 6, and 7 are typically going to be grouped together because they deal with applications. At the OSI Layer 5, this is the session layer. We can create and terminate the ability for a device to communicate with either a server, cloud, or other device that is hosting a software application. The session layer allows our end user devices to create the environment on our devices to be able to run the appropriate application files. At the session layer, we have the ability to perform synchronization. This is where we can manage all of the data that's being exchanged between applications, between endpoints, servers, and any other device or host that is involved in creating and maintaining this session. OSI Layer 6 is our presentation layer. We're going to take all of the data formats that are being sent between our application sessions and translate them into the correct format for our users' interfaces. This could be making sure that the application can run in the correct version of a browser, an application that is going to be hosted on a cloud server. And we need to make sure that our end users' devices can run the application in the appropriate file package. At the presentation layer, we also will perform encryption and decryption of all of the appropriate data. If we are encrypting data, we're making it unreadable to unauthorized third parties. If we are decrypting data, we are taking the encoded, encrypted information and translating it into a plain text or human readable form. Presentation layer will also use a feature called compression. It can take multiple data packets or files that are being sent, and we can compress them down into a smaller file size to help us to conserve our bandwidth. And the last layer in the OSI model is Layer 7, the application layer. The application layer can perform many different types of services on our network. We can use applications for email, file transfers, web browsing, and any other job function that we have created an application that is relevant to our organization or business. At OSI Layer 7, we use a feature called API, an Application Programming Interface, how an end user can interact with the application and perform functions and processes within the application itself. At the application layer, we also can do network sharing. We can enable all of our application files to share resources to multiple users across our network. So let's go ahead and recap the different layers. We have OSI Layer 1, which is the physical layer. This is going to be all of our cabling, our data signal, the data speed, and our network topologies. OSI Layer 2, the data link layer. This is where we're going to be using our network switches and MAC addresses to send and receive data within our local area networks. OSI Layer 3, the network layer, is when we are going to be working with our routers and sending data to and from based on IP addressing. OSI Layer 4 is the transport layer. We use TCP and UDP as the primary protocols to send our IP traffic across the transport layer. OSI Layer 5 is the session layer. This is where we can create and terminate sessions for our users to communicate with applications. OSI Layer 6 is the presentation layer. This is where we convert all of our different data packets into formats that are readable by our end users' devices. We also perform encryption and decryption of our data at the presentation layer, OSI Layer 6. And finally, OSI Layer 7, the application layer, where we perform all of the network services using applications. This can be email, web browsing, and others. And the application layer will allow us to have network resource sharing, where multiple users on our network can access the same application environment. It may be helpful for you to use some type of mnemonic device to help you remember all the different layers. One way I like to use is going through the acronyms. All people seem to need double pepperoni. I'm a pizza lover. And that's a good way for me to remember all the different layers. All people seem to need double pepperoni. That will conclude our discussion of Section 1.1, the OSI model. In our next episode, we will move on to Section 1.2 in the objectives and discuss network appliances. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.